So unfortunately, this one's going to be, I don't have any slides for video. This is going to be a little more interactive, so this one you might want to cut in pretty tight on the screen.
Do you want me to go ahead and leave you out? Just do the screen?
Get just a little bit of me. I'll stay this close to the screen, so just where I'm just barely in the screen. I'm going to set my my terminal font much bigger as well. I'll have to eventually go back to
Don't move the TV now.
Python 3. No, let's start up Python 3, and I'm not a Python expert, so this is where we're going to be even a little bit more interactive with some folks who are Python. All this stuff runs much faster in C, but you know, OpenCV is a nasty complex library. Most of the optimizations that we'll really be seeking for an embedded device can largely be done by choosing smarter algorithms, doing less copy. We don't necessarily have to go to C. I would say in general, if you're halfway there, going to C will get you there. If you're 10 off, yeah, going to C is probably just going to C alone is probably not going to make the difference, right? You have something more fundamentally algorithmically of a challenge. Make sure that you measure the performance of your application and make sure there's headroom, right? Allow for variances and stuff. So you can use top, but there's some other utilities that we can measure CPU utilization as well. We're going to start by import CV2. I'm gonna have to go pull other reference examples as I'm trying to think about this. But this one's going to take a little while to load. When you work with Python and OpenCV, a ton of it is in CV, but a ton of it uses this other library called NumPy. If you're not familiar with NumPy, it's which a lot of the matrix operations are done in Python with. So overall, the OpenCV is becoming more and more Python friendly. Over time, they're getting better integration with Python, and they're moving, as you get newer versions of OpenCV, they're using more NumPy objects and less, at least I believe that's the trend, is more NumPy objects and less native OpenCV objects. So you can do a little bit more manipulation with NumPy. What's the inspection? What is list? What's the introspection command in Python? dir. Think like DOS because it's so backwards. No? It's not dir? There we go. Python has some introspection capabilities.
dir open
dir open parentheses CV2. So this is going to give me a list of the members within the CV2 object. Enough computer science I could use members and objects, and those make sense. Yeah. Enough programming computer science stuff to use those terms.
All the functions. Not sure functions.
The documentation on OpenCV is, in my opinion, atrocious. There's really not much getting around it. You kind of have to try some things and see what works. So doing things like introspection is really helpful to kind of understanding what the library is actually doing, because there's tons and tons and tons of examples out there that just won't work. but we can go back and we can look at so like image, show, like a lot of these are designed to display things in the in X11, right? To actually like display things in a GUI. You could do you can open a CV window and display things within the CV window. For Beaglebone Blue, the best way to do that is to start a VNC server. You can actually run X Windows in a VNC server over the network. That's useful for some amount of debugging if you want to get some visualization.
Is that difficult?
It's non-trivial.
Yes.
I wouldn't say it's difficult. It's just non-trivial. It's large because you have to have the X Windows subsystem running. Otherwise, these images don't ship with the X Windows subsystem. We don't ship with the GUI on the Blue because we're not expecting you to run a GUI.
So for doing manipulation of images with OpenCV, that's the recommended method of passing the images to the computer.
My recommendation. My recommendation is that you write to files and display the files.
Okay.
If we look at, like this is the example I keep going back to because this is the expects to be running as root. This is the one that I've been playing on and getting to work and stuff where I've been capturing things. So this is my blue donkey car. It's an autonomous vehicle that's basically a line follower.
Yeah, I've seen Donkey Car.
What's that?
I've seen Donkey Car.
Yeah. So this is using the same donkey car frame, but it's using a Beaglebone Blue instead of a Raspberry Pi. And then the first code I built out, instead of using TensorFlow, was to simply use OpenCV and do a line follower, just so that people can have some quick experience with something working. The first thing you have to do with donkey car code is train the model before it can do any autonomous driving. So starting with some just classic computer vision, you can start driving quicker. I use some socket communication to try to send commands. So I start one Python thread that's running my vision loop, and doing all that processing, and then I just start a separate socket interface in order to communicate to it. I just found that trying to interact through standard in and out was cumbersome. So I just kind of split my I/O versus my and yeah. You've got your I/O through Pygame and the joystick.
Yeah.
So that's your one. You have that nice I/O mechanism. You have your output through Flight, so that's good. Right. I was doing some. I was also outputting some text regarding like where is it detecting the line, like just how many frames per second is it currently running. So I was dumping that out of a socket so I could monitor that separately. I also found it really useful to do this thing where you'll see this binary view thing in this code, wherever binary view. It actually creates a frame, and I write this to a file using IamWrite. So with CV2 IamWrite, I can write a frame of video into a JPEG file, all right, or a PNG file. I was using PNG. What I found was really easy was just to keep overwriting that PNG file, and then just open it up in the IDE. So I'm going to do that manually right here. What is it? Capture. There we go. So you have to do CV2 video capture. I'm gonna try to leave all these settings by default, but you can tune the frames per second. You can tune the capture mode to be more optimal for your camera, and I found that there's been significant latency differences. I found that my biggest problem with OpenCV and the camera interface is that OpenCV adds a ton of buffering. I'm really looking at patching OpenCV to remove that buffering, or remove a lot of the buffering. I know that TI has the TI releases a version of OpenCV. I believe that they, like for their SDK, and I believe that in that version, some of the buffering is reduced. It causes a lot of latency. OpenCV is optimized more for throughput and less for latency. When you're doing mobile robotics, you care about latency, like first and foremost, right? So you can adjust the frames per second. You don't want to bring in more than what you need, so turn that down. Some of the modes will be faster coming out of the camera. We did some for stuff we were doing. We actually built a test bench where when we detected an object, we turned on an LED, and then we kind of pointed it back on itself so that we could measure the latency between the when the LED came on, and like so we can measure the latency in the camera. It's an experiment I can point you to. I found it really useful for profiling the cameras and also selecting these video modes. Because you want it to be responsive. All right, so reducing your frame size so you can use the capture.set. Oh, did I forget to save off the video? I did. That was silly. Let's go ahead and save it. I can start over again. So you can also do things like to try to have the some of these cameras, the auto exposure is a little over aggressive, and you want to do some things in software more. So you can most of these cameras you could turn off the auto exposure, and then you can deal with exposure changes in your software because it makes tremendous differences in the values you're getting from the camera. But either they, because a lot of times you'll get this like real ugly spike in the data by leaving on the auto exposure, where it gets either really bright or really dark, and then it switches up on you again real quick. So it results in some undesirable effects for machine vision. You'd rather just get bright as it turns.
Without the lights even changing in this room, if my scuttle pointed towards the toolbox and then turned towards the white wall, if it was trying to detect any features in front of those items, then the exposure is going to drop down drastically as soon as I turn towards the white wall, because most of the pixels will be high value.
Exactly. So you lose the ability to kind of leverage the previous gathered information because you're looking at a totally different exposure rate. So yeah, so coordinate your exposure changes with your algorithm based on what you're seeing as the balance is much more effective. Setting some frames here that I overwrite. I don't know if this was effective or not, but for me, I wanted to try to drop old frames as quick as possible. So I ran a parallel thread that captured images. I don't know if this is all that effective, but I captured images and then threw them away. So I just kept a global data structure of what the latest image is, and I just referenced that data structure. There's potential for tearing, but not. Yeah, there was, I don't think it's that significant. Yeah, I'm doing some, so I capture into one and then just copy if it's good. On 2 separate threads, and then this global frame, that frame in is a global. So I referenced that from the other thread, right? So I have one processing thread and one capture thread.
So frame in is a JPEG file?
No, frame in is
Set of
the data. It's the
bytes.
captured data. All right. So first I open the camera. I can set any different